Roman 2 says at least A and B. So when you're told at least A and B, probability of at least A and B, what that means is we get A and B alone or more. So if we are getting A and B or more, it is where we have gotten A, we have gotten B, and we have also gotten what? C, as the first case. Or probability where we get A, we get B, but we have missed C. And that's all. That's all. So if that is all, then this will be 0.3 times 0.4 times 0.6 plus actually this one that is up here 0.048. We don't have to rewrite it again. 0.048 0.12. 0.12. Good. The next one is C and D. Ability of getting C and D. So probability of C and D. Now we look for where we have gotten the two of them, C and D. And I think it's just here. It's only one. This one. C and D. So it is we miss A, we miss B, we get C, we get D. Yeah. So that one is the probability that we missed A, we missed B, we got C, and we got D. So this will be 0.7 times 0.6 times 0.6 times 0.8. 0.2016. That is the answer. 0.2016. I have just C. So if you are looking for just C, probability of just C, this is the probability that you have missed A, you have as well missed B, you got C, but then you also missed what? D. You also missed D. So the probability of missing A is 0.7, B is 0.6, getting C is 0.6, and missing D is 0.2. Zero point 0.0504. And just D, probability of just D that is, you have missed A, you have missed B, you have missed C, but you have gotten D. So this is 0.7 multiplied by 0.6 multiplied by 0.4 multiplied by getting D, which is 0.8. 0.134. 44. Good. Okay, so that is what you will do. And in your past papers, you will do for your assignment, you do question 8. You do question 8 in your assignment, in your handout. And then you do this question of September 2015. Just note somewhere, September 2015, question 5A. September 2015, question 5A. Yeah, I think you can just do those two. The others are in the next topic. In the next topic, we'll also be coming to draw the trees. So we can reserve them there. So following our notes, we can see the next thing now is what we call combinations and probabilities. But before we discuss that, let's discuss something we call, or the title of that is methods used to count in probabilities. Methods used to count in probabilities. So we shall list them, then we discuss each. So the first one is set theory. The second one is probability tree. Probability tree. The third one is permutations. Permutations. The fourth one is combinations. Combinations. Those are methods that we use to count in probability theory. We already have used set theory, and you remember in answering these questions, we would be asked, how many are these, how many are these? So in answering those questions of how many, that was counting. We have just concluded probability trees, and in these probability trees, the probabilities that we have gotten here, if we had been told, for example, there were these number of items. For example, in the question we have done, if you have been told all the items were 500, then you just take the 500, you multiply by that probability, and that will tell you how many items. So it's also used in counting. So because we already have discussed these two, we then go straight to permutations. So write permutations. Let's start with permutations. Permutations. Permutations, and write that this is a method used. This is a method used. This is a method used to determine the number of ways, in which different items can be arranged, in a particular order, while selecting R items at a time. Stop. Permutations recognize positions. The computation is number of ways is equals to NPR. Now this NPR is given as n factorial. You divide by n minus r factorial, where this sign here is called factorial notation. And 0 factorial is 1, and 1 factorial is also 1. Audience, good morning, welcome, and mute yourself. So, because we have calculators, I will not spend a lot of energy on showing you the manual way. So get your calculator and tell me whether you can see this side. I mean this side. You don't have a calculator?
Yeah. I think that's the same as you get.
From tomorrow, I'm not allowing you guys. Tomorrow, kuja bila kufukuza wewe. I today have a Zero ni deep. So I was saying you check whether you can see this sign NPR. Collins, can you be able to see it? Have you seen it?
Yeah.
Okay, if you have seen it, can you see this one also? Factorial? So if you have seen it, so below that, pick illustrations. Illustrations. If we are told to get 5 factorial, manually, this is how you go about it, because the factorial notation is a multiplication of natural descending numbers. So this one will be like this. It will be 5 times 4 times 3 times 2 times 1. Multiply that way. 120. But if you are to get it in the calc, press 5, then press shift, then press the button where there is that factorial, so that on the calc now you have 5 factorial. Then press equals. Yes. So similarly, if I was tell you to give me 16 factorial, it will be 16 times 15 times all the others back times 1. But now using the calc, you just press 16, then you press shift, you press factorial, and you press equals. What do you get? That's really what appears there, but unless it's a math error.
2.09.
2.09
10
times 10 power 13. Good. If now you are told to select 5 items, or rather to commute 5 items, selecting 4. Now using the formula, this would be 5 factorial over 5 minus 4 factorial. But because I want you to be using the calc, I'm going to show you how to use the calc. So in using the calc, just press 5, then press shift, press the button where you can see NPR. When you do that, now on the screen you have 5p. See there? Then press 4, and then press equals. 120 ways. So that means if you have been given 5 persons, na umewapia wapange waine, unaweza wapanga in 120 different ways when you're observing the position. Similarly, if you are given 12 commute 7, 12 commute 7. So again, you will say 12 shift NPR so that you get 12 P. See the 12P on the screen. Then you press 7 and then you press equals.
981,680.
680. Good. That is how we do the computations. So it is as simple as that. So as I've said, I don't want to go to the manual way. You already have the calc. Remember, the purpose of a machine is to make what? Easy. Good. So let's now look at combinations. Combinations. Combinations, and we write that this refers to the number of ways. This refers to the number of ways in which n different items, the number of ways in which n different items can be arranged in any order, and different items can be arranged in any order, while selecting R items at a time. First of all, combinations does not recognize positions. Combinations does not recognize positions. It's computed as n combined R is n factorial n minus R factorial R factorial. So the same now we use the same procedure when you're using a calculator illustrations. So if you are told to give me 5 combined 4, 5 combined 4, it is our calc has, you require to go through shift again, but some other calculators do not require to go through shift. So press 5, press shift, press the button where you can see NCR, so that now you have 5, 6. Press 4, then press equals. 5 ways. The same thing I would like you to do 12 combined 7. 12 combined 7. So press 12, press shift, and press NCR, press 7, 792. Now, what I wanted you to see is that when we are not recognizing positions, you can see the number of ways significantly reduced compared with these ones. You see here we had 120 ways, but here you just have 5 ways. Here we had almost 4 million. You can see it is reducing to 792. Yeah. Okay, then down there, Nika, Combinations are used in computation of probabilities. Combinations are used in computations of probabilities. Are used as follows. Probability will be equal to desired ways you divide by all possible ways. Desired ways you divide by all possible ways. Desired ways divide by all possible ways. Okay. There is question 9 in our handouts. Question 9 in our handouts. Audience, I don't know whether you have the handouts, whether you have joined the group by the time it was posted. Do you have it?
Yeah.
Oh, good. So if you have it, then question number 9. Nasema, a committee of 4 persons is to be appointed from 3 officers of the production department, 6 from purchase department, 2 officers of the sales department, and 1 chartered accountant. Find the probability of forming the committee in the following manner. There must be 1 from each category. So, the first thing is to know all possible ways. All possible ways is the first thing that you need to get. Now, all the possible ways is the number of persons. We have 4 guys. We have 3. No. A committee of 4 is to be appointed from 3, 6, 2, and 1. So it is like this. It is 3 plus 6 plus 2 plus 1. That is visible. So I'm saying this is 3 plus 6 plus 2 plus 1. We combine 4. So this is there are 10. No, there are 11. There are 12. There are 12. So 12 combine 4. Put in the calc. 12 combine 4.
495.
495 ways. 495 ways. 495 ways. So if that is what we have, So those are the number of possible ways. So Roman 1 inasema there must be one from each category. So A, one from each category. So if you are told we want one from each category, the desired weights is we get one. How many categories do we have? We have production. So one production and one purchase and one sales and one accountant or accounts. See, that is what we mean. Yeah. So if that is what we mean, then you see we are connecting them with the word and. So that becomes multiplication. Yeah. So from the production, we have 3 guys. So 3 guys choose 1. Then times purchase, we have 6. So from 6 guys choose 1. And sales, we have 2. So from 2 guys choose 1. And accounts, we have 1. So from 1 guy choose 1. So these ones, we just put them in the calc. 3 combine 1 times 6 combine 1 times. If finally we say equals. That is 6 weeks. And therefore, the probability will be the desired 36 over the possible 495. That will be the probability. The next one is saying we should have at least one from purchase. So part B, at least one from purchase. Now, when you are told at least one from purchase, the desired ways will be one purchase and 3 others. Because we need 4 guys, So 1 purchase and 3 others. So purchase ikona watu 6. So 6 combine 1, and because in total we have 6 persons, 12 persons. When you already have selected 6, we are left with 6 others. So 6 combine 3. Mm-hmm. 120. Or 2 purchase and 2 others. 2 purchase and 2 others. So this will be 6 choose 2, 6 choose 2. 30. Or 3 parties. This 225. 225. Or 3 patches, 1 other. So 6 choose 3. And 6 choose 1. You have 120. Or 4 patches and 0 other. So 6 choose 4 and 6 choose 0. So total is 120 plus 225 plus 120 plus 15. Because we are saying all, all becomes plus. All becomes plus.
80.
Huh?
480.
480. And therefore, our probability, the probability for that, the probability will be 480. You divide by 495. 480 you divide by 495. Good. The chartered accountant must be. So if you are told the chartered accountant must be, you see for this one, tumesimamia 4, because that's the maximum number of persons we want in the committee. Yeah, that's the maximum. Although the purchase guys are 6. So if the chartered accountant must be there, chartered accountant must be there. Now, if the chartered accountant must be there, the desired ways will be 1 accountant and 3 others. 1 accountant and 3 others. So it is 1 combining 1 because we have 1 accountant, and then we are left with 11 other guys. So 11 choose 3. 11 choose 3. One, 6, 5 ways. So the probability will be 165 you divide by 495. Okay, 0.33. See, tumeelewa hiyo. Let's go to question 10, but that now we will be a bit free. We will not try to everything because we already have had an idea. Question 10. Question 10. A committee of 4 has to be formed from among 3 economists, 4 engineers, 2 mathematicians, and 1 doctor. What is the probability that each of the 4 professions is represented? So in A, the probability that each is represented is going to be like this. The desired is from 3 economists we have 1. And from the 4 engineers, we have 1. And 2 mathematicians, we have 1. And from 1 doctor, we have 1. Those would be the desired weights. So this one, you just divide by the possible weights. The possible is, if you add this one, 3 plus 4 plus 2 plus 1 is what? Is 10. So from 10, we choose 4. So unaweza weka hizo vitu zote kwa calc and get the answer that way. 3 combine 1 times 4 combine 1 times 2 combine 1 times 1 combine 1 equals, you divide by 10 by 4. That's 0.1143. Then part B, the probability, we are told what is the probability that it will consist of the doctor and 1 economist. So we want 1 doctor, so 1 choose 1, and 1 economist, at least 1 economist. So when you're told at least 1 economist, now economists, there are 3 of them. So from the 3, you choose 1. Now, so far, we've got our 2, so we still need 2 others. So, and there were 10, so from the 6 others, we choose 2. That is the first possibility. The first possibility, where we have 1 doctor, 1 economist, and 2 others. The second possibility is you have the doctor, and because we are told at least 1 economist, now from the 3 economists, we can have 2 guys. And then now from the 6 others, we have 1. From the 6 others, we have 1. The next one is from 1 doctor, 1. From the 3 economists, we have 3 guys. 3 combined 3. And then from the 6 others, we get no one. So all that you will divide by 10 combined 4. 0.3. Good. 0.3. So on your own, you shall handle the question that follows that. That is question number what?
11.
Question number 11. So, that's okay. Let's now look at the next item in our notes, which is called expected value, variance, standard deviation, and coefficient of variation. And coefficient of variation in probabilities. So, when we looked at descriptive statistics, we came across these measures. The measure of central tendency, which was the mean, the measures of variation, these ones, and we gave the formulas that are used when the data is grouped and when the data is ungrouped. Now we want to see how do you compute the same in probabilities when the data is given in probabilities. Question 12, I had put there to remind you about the descriptive statistics. So you will do question 12 on your own, the same way to report on jibu kwa descriptive statistics. So remember, yeah, you should, and if you don't, you will find your notes. So let's go to question 13. Question 13, we are told an investor has shillings 100 available to purchase shares in either chemical or brewing companies. His broker has provided him with the following estimates for the likely returns over the next 12 months. We have the possible annual returns and the probabilities. What is the expected, what are the expected annual returns for the chemicals and brewers? Okay, so I want us to start with that is now question okay, sorry. This is question 13. And I want us to do with chemicals. This is XI. We have the probability. This is probability of XI. Then we have XI multiplied by probability of XI. Then we have XI minus X bar squared multiplied by probability of XI. Multiplied by probability of XI. So get that point. Then you multiply these two, you get the total here, the total here. But What do you get here? This must be one. Then here. Well. Okay, so now down here become expected value. Expected value. And this expected value is usually written like this. It is expected value of X. And this is what in our descriptive statistics we refer to as the mean, X bar. So in computing this, we say it is the sum of Xi when it is multiplied by probability of Xi. When it's multiplied by the probability of Xi. So when we have done that, the answer is what? It's 12. So when we have multiplied this and we have summed, the answer is 12. So when you come here now to get the variance, pick up the variance. Now variance delta square is given as sum of Xi minus X bar squared multiplied by probability of Xi. xi minus x bar, you square, you multiply by probability of xi. So what we shall do, tutarudi kwa hii table, tuseme minus 20 minus 12. You square, you multiply by 0.05, get the answer. Then you say minus 10 minus 12, you square, multiply by 0.1. Then you say 0 minus 12, you square, multiply by 0.2. You do that for all of them, you say 40 minus 12, you square, multiply by 0.05. Then you give me the total down here. You don't have to write all of them like I'm doing it. You can just key in the figures, you write the answers. Or I think maybe one or two to guide you how we got that. You are through. What did you get? Yeah. 246. So that 246 is the variance. 246. So if that is the answer there, the next one is called standard deviation. Standard deviation. Now, standard deviation we know so well is the square root of the variance. So the square root of 246. $15.68. The next one is coefficient of variation. Coefficient of variation. Now the coefficient of variation, CV, we know is given as standard deviation. We divide by the mean times 100. Standard deviation, we divide by the mean times 100. So this is the 15.68 divided by the mean of 12 times 100. That's how you get the CV. $130.67. Good. So I believe you will be able to draw another table for brewers. You see, the question was about two things. There was brewers and chemicals. So the returns are the same, probability ndio tofauti. So utaweka two returns hapa hivi, probability ndio utabadilisha, then you compute these four things for brewers. And with that, you also compute question 14 is on the same understanding. So that when we meet now in the next lesson, we shall look at binomial probability distribution. I'm suggesting that we be starting our classes at 6. Is it possible for you now that you come physically? Is a tall order?
It's a tall order, but
okay. If it's a tall order, let's then maintain our 6:15. Then as we go by and by, we shall have some makeups. How busy are you on Saturdays? You work?
no, but I do have another task.
Oh,
From 8:30 to 10, and another so maybe I can do that.
11 you are free.
Yeah, from 11 to maybe
Okay.
1.
So then we shall look for a day, or either one Sunday. You come here physically on Saturday?
No. At times I'm able to attend sometimes.
Okay. So we shall organize whether we shall have it on Saturday 11 to 1. Ama it will be on Sunday and preferably Saturday. Yeah, preferably Saturday, but not this coming Saturday. Yeah, not this coming one. Even me, Saturdays are usually very tight. But if we can be able to squeeze those 2 hours there, it will be better than coming on a Sunday.
Yeah, sure.
Yeah. So thank you, Collins. Tupatane kesho. Si kesho ndio tunapatana, eh?
Yes.
Okay, thank you.